Transformers equations. These are separates only, they are quite tricky. Lots of numbers and you've got to be very careful. So we've got two equations first of all. So we've got Vp over Vs is equal to Np over Ns. And you've got to be aware of what these subscripts mean, which is P stands for primary, so this is the voltage across the primary. This is voltage, and that's voltage across, or the potential difference across the secondary coil of our transformer. Here you've got number of turns on the primary and number of turns on the secondary. What we've also got as well is Vs times Is is equal to Ip Vp. Well, express it, you can call it Vp, Ip equals Vs, Is, it doesn't really matter. What you do need to recognise though is that power is equal to IV. So here what we've got, let's say Vs, we've got power across the secondary, and that will be equal to Vs, Is. Okay, now that is going to be equal to the power across the primary, which is equal to Ip Vp. So it's a way of checking your answer. So right, and here we go. So let's do question number 1. So calculate the secondary voltage. So we need Vs of our transformer. Primary voltage is 230 volts. Number of turns on the primary coil is 12, and the number of turns on the secondary coil is 72. So we need to calculate Vs. We know that Vp is equal to 230 volts. Number of turns on the primary, Np is equal to 12, and number of turns on the secondary is 72. So what we've got then is, writing our formula is Vp over Vs is equal to Np over Ns. So inserting our numbers, what we've got then is Vp 230 divided by Vs, which is equal to 12 divided by 72. So what I would suggest that we do is, rather than rearranging all this, what we can do is we can just get rid of this on this side, if you like. So 12 divided by 72 is equal to 0.166. Okay, now that leaves us with 230 over Vs. Okay, rearranging this will give us Vs is equal to 230 divided by 0.1666, and that will leave us with 1380 volts. Okay, now primary voltage, so number 2, sorry. What's primary current in the transformer? So primary current, that's going to be Ip, sorry. In a transformer, if the primary voltage is 20 volts, so Vp is equal to 20 volts, and the secondary current is 2 amps, so Is is equal to 2 amps, and the secondary voltage is 4 volts. So we've got Vs, Vp, Ip, we need to find Is and Vs. So what this means is we're going to have to use our second transformer equation, which is Vp Ip is equal to Vs Is. So Vp is 20 times Ip is equal to Vs, which is 4 times Is, which is 2. So you've got 20 times Ip is equal to 8. So Ip will equal 8 divided by 20, which will give us 0.4 amps. So such a slick little girl. So I'm not so sure we need any more Lou Reed and transformer. Right, calculate the primary voltage of a transformer if the secondary voltage is 200 volts and the number of turns on the primary is 40 volts and the number of turns on the secondary is 12. I'll give you three significant figures. So calculate the primary voltage. So VP, we don't know what that is, but we're told that the secondary voltage VS is equal to 200. Number of turns on the primary, MP, is 40, and the number of turns on the secondary is 12. So quite simply we can write our formula. VP over MP is equal to NP over NS. We can slot our numbers in. VP over NP, VP, sorry, which will give me VP over VS, which is 200. I apologise for that. Is equal to NP, which is 40 over 12. So that's going to give me, I'll work it out, we've got 440 divided by 12. So we've got 40 divided by 12, and that's going to be equal to 3.33333, 3.333. So we're now going to have VP over 200 is equal to 3.333. So rearranging this, we can see that VP is equal to 200 times 3.33, 200, which will give me 666.66666. So rounding this up now, we need 667 volts. That's three significant figures printed out there. Right, number 4. So number 4, calculate the secondary current. Secondary current, so that's IS. In a transformer, the primary current is 40 milliamps. That's 40 milliamps, and the primary voltage is 25 volts. Voltage on the primary is 25, and the secondary voltage is 230. Okay, so that's equal to 40 times 10 to the minus 3. Now, writing in our formula, we've got VP IP is equal to VS IS. Substituting our numbers in, that will give us 25 times 40 times 10 to the minus 3, and that will be equal to 230 times IS, which we don't know. So now what we've got is 25 times 40 times 10 to the minus 3 is equal to 1. So 1 is equal to 230 times IS. So that will give me IS is equal to 1 over 230, which is 0.004 amps. So I'm going to write in there 1, 2, 3, 4 milliamps. Okay, moving on. So we've now got 2 more questions. Now these 2 questions here have got errors in them, so we do apologise for these. So what we've got to do then is we are finding, it says here that we are finding the current in the secondary coil. So we're finding the current in the secondary coil. So this is IS, and we don't know what that is. So what is the current in the secondary coil of a transformer if the primary coil is 40 turns? So NP is equal to 40, and a voltage of 120. So we've got a voltage on the primary of 120 volts, and the secondary coil is 200 turns. So NS, sorry, is equal to 200. And then it says here that there is a current of 6 amps in the secondary coil. This should read primary. So we have a current of 6 amps IP in the primary coil of 6 amps. So these are numbers. So we're finding the current in the secondary coil. So we're finding IS. So we need VP IP is equal to VS IS. So let's have a look what we've got. We've got VP, we've got IP, we don't have VS. Okay, and up here we don't have our voltage in our secondary. Okay, nor do we have current in the secondary, so we can't use this. But what we do need to do is we've got MP and NS. So using VP, MP and NS, VP over VS is equal to MP over NS. We can actually use this to find VS and then substitute it back into this equation. So let's find VS first. So we've got VP, which is 120, divided by VS is equal to MP, which is 40, divided by 200. So VS, okay, will equal, let's go, 40 divided by 200. So got 40 divided by 200, which gives us 0.2. So we have, let's think, so VS is going to be equal to 120 divided by 0.2, which is going to be equal to 120 divided by 0.2, 600 volts. So we've now got voltage across the secondary. Now, if we take the voltage of the secondary at 600, the voltage of the primary was 120, so it's a step up. Now, if it's a step up, then voltage goes up. Now, because power is the same at the input and the output, then in order to keep this, then the current must go down. Okay, so the current goes down. So I'm given my primary current as 6 amps, so whatever number I get should be lower than 6 amps. Okay, so I've now got VP IP is equal to VSIS. Slot my numbers in. So I've got VP, which is 120, times IP, which is 6, and that's equal to VS, which is 600, times IS, which we don't know. So over here then, I've got 600, 720 is equal to 600 times IS. So now we've got 720 divided by 600 is equal to IS, which in this case 720 divided by 600, which will give me 1.2. So I've got 1.2 amps, which is actually lower than my primary current, so that must be pretty much correct. You could check this, but I'm not going to in this video because I'm already up to 14 minutes. So next one, again there's another error in this one. This one says calculate the number of turns on the secondary coil of the transformer if the current in the primary coil is 2 milliamps and the secondary current is 40 milliamps. The secondary voltage is 12 volts and there are 15 turns on the secondary coil. Well, it's asking me to calculate the number of turns on the secondary coil, but it's also telling me there's 15 turns on the secondary coil. Well, what this should be and should read as being this has been primary. So what we're going to do is we're going to calculate the number of turns on the primary coil. So NP, we don't know what that is. Okay, but we do know calculate the number of turns on the primary coil of a transformer. The current in the primary coil is 2 milliamps. So IP is equal to 2 milliamps, and the secondary current IS is equal to 40 milliamps. The secondary voltage, VS, is 12 volts, and there are 15 turns on the secondary, so NS is equal to 15. So I need to calculate the number of turns on the primary, so we'll take VP over VS is equal to NP over NS. We don't have NP, so we've got NS, we've got VP, oh no we haven't, we've got VS though, so the first thing we can do is work out VP because, okay, we don't have it here, we've got two unknowns in this. So now just calculate VP. So I know that VP IP is equal to VS IS. So calculate VP. I've got IP, yeah. I've got VS, yeah, and I've got IS, yes. So I can substitute some numbers in and find VP. So VP times 2 milliamps is equal to 12 times 40 milliamps. So that will give us an answer of right, MVP will equal 240 volts. So VP is equal to 240 volts. Now we've got VP, we can substitute it into this to find NP. So we've got 240 divided by VS, which is 12, which is equal to NP all over NS, which is 15. Okay, so what we've got then is, we'll just do 15 times 240 divided by 12 is being equal to NP, and that should give us 300. So let's go 15 times 240 is equal to that, divided by 12, and that's equal to 300. So we've got 300 turns on our primary. Right, and last one. So, and I do like this question. This is a nice question. This is your 5-6 marker. So a transformer has 500 turns on the primary coil and 7,500 turns on its secondary coil. Potential difference across the primary coil is 250 volts. The primary potential is 150 volts, we've got that, and the current in the primary coil is 500 milliamps. How much charge will flow in the secondary coil if it's turned on for 3 minutes? Okay, so I've got quite a bit of data there, so I'm after charge, which is Q. Okay, now I do know that time is equal to 3 minutes, which is equal to 180 seconds, and I also know that Q is equal to IT. Now, how much charge will flow in the secondary coil? So what I'm after is I'm after charge in the secondary coil, so I must need the current in the secondary coil here. So I'll put this little subscript here. So, right, and let's have a look what else we've got. So, transformers 500 turns in the primary coil, so MP is equal to 500. I've also got NS is equal to 7,500. Potential difference VP is 150 volts. Okay. So I need IS. So I know that VP times IP is equal to IS times VS. I haven't got VS, I haven't got IS. So I'm going to need to find some missing numbers, so I can substitute in this to find VS, which I can then substitute into here. So I do have NP and NS, so that's telling me then that I've got to use VP over VS is equal to NP over NS. Swap my numbers in. I've got 150 over Vs, which I don't have, and that's equal to 500 divided by 7,500. So, okay, what we can say now is I've got 150 over Vs is equal to 500 divided by 7,500 divided by 7500 is equal to 0.06. Okay, so Vs is going to be equal to 150 divided by 0.06. So 150 divided by 0.06, and that will give me 2,500. Now I'm just going to check that. So I've got 500 divided by 7500, which will give me 1 over 150, which is 0.0666 recurring. So I've got 150 divided by 0.066666. That is equal to 2250. Okay, so that's my voltage across my secondary. Now, something to note about this diagram as well is that the diagram's the wrong way around. Okay, because it's a step-up transformer. It tells you it's a step-up transformer right at the beginning. 500 turns on the primary, 7,500 on the secondary coil. So, okay, the input's here if you like, and the output's here. So, what we've got then is we've now got Vs. So once I've got Vs, I can now use it to find Is. So we've got Vp Ip is equal to Is Vs. So we've got Vp, which is 150, times Ip, which is so what's I across my primary, 500 milliamps, and that is equal to Is, which is, well, I don't know, that's what I'm trying to find out, times Vs. So we've got Vs, well, I've just calculated that, that's equal to 2250. So 150 times 500 milliamps gives me 75. 75 is equal to Is times 2250. So Is is going to be equal to 2250 divided by 75. Sorry, 75 divided by 2250, and that is equal to 1 over 30, which is 0.33333 recurring. So I've now got Is. I can now do Q is equal to Is times T, because I'm after the charge flowing in the secondary coil. So I've got Q is equal to 0.333 times time, which is 180, which gives me an answer equal to 6 coulombs. So that's my answer. So quite involved.